All right. If you are on this video, it means you just kind of want to see this idea of properties of logarithms expanded a little bit. Excuse me. So problem 4, how do we use a logarithmic scale? So in chemistry, we have the pH balance, and we've seen this before. It's negative log of H plus, and that describes the pH balance. H plus is the concentration of hydrogen ions for a household ammonia. Now they're actually giving us one. So household ammonia is 10 to the negative 11th. That is the concentration of H plus for ammonia. Now then we have vinegar. Vinegar has an H plus of 6.3 times 10 to the negative third. That's for vinegar. What's the difference? So I thought I'm just going to go ahead and screenshot what they did. So we have our basic pH equation, which we've talked about before. And to find the difference of the two, we're going to take the ammonia and we're going to subtract the vinegar. And when we do such, we will end up with, let's take a look, negative log of H plus A, and then distributing that becomes a positive here, and then there's our vinegar. And what did they do next? They rewrote it, so they just put it like commutative property. They put the vinegar first minus the ammonia, and then that's just they're rewriting it. Let's see what they did next. You can replace your vinegar with what they told you it was, and you can replace your ammonia with what they told you it was. And then they expanded the logarithm. So remember that multiplication turns into addition when you put it in expanded form. So that's what happened there. They took this item and they put it into two terms using addition. And then they cleaned up this middle term. Now, I'm wondering, do you know how in the world they changed it to a minus 3? Remember, that logarithm is really a base of 10. So it's really saying 10 to what power is 10 to the negative third? That's why they have a minus 3 there. Just trying to explain that. And then the same thing happens here. 10 to what power is 10 to the negative 11? So let's think about that. The answer, that's a question mark, the answer would be negative 11, but when you do minus negative 11, that turns into plus 11. And then you can type it on your calculator because it's all in a base of 10. So log of 6.3 minus 3 plus 11, essentially plus 8, ends up giving you 8.8. So they're just showing you how you can expand it and use those. So the end is the pH level of ammonia is about 8.8 greater than the pH level of vinegar. All right, let's keep going. This was really why I wanted to do this second video, not necessarily because of the pH one, but I love knowing why things work the way they work. And for me, the change of base formula is one of those things that I think we can really see. So let's say we're given a logarithm that has a base of b of m. I'm going to prove to you that you can make it a common base. It doesn't matter if you use 3 and 3, 4 and 4, or what you use. We use 10 and 10 because we live in a base 10 society. But you can write it as a common base as long as you put log of that common base of m on the top and log of that common base of b on the bottom. Now, we did this in the notes already, but we just kind of like took it for granted. If you're wondering why that works the way it works, here you go. Here's how it was derived. So the first thing they did is they said, okay, we have this logarithm in a base of b of m that we cannot get in our calculator. So they ended up multiplying the top and bottom by a common log of b. Remember the base was b? So they said, okay, I'm going to pick a common log and I'm going to do that common log of my old base. And I'm going to do that on the top and the bottom because really when I multiply top and bottom by the same thing, I'm not changing the problem. I'm just multiplying it by 1. Very similar to when we rationalized, if you know that word. Okay, and then let me delete all that so I can write some more. They said, I remember that if I have a logarithm being multiplied by something in front of it, so there's like a multiplication symbol here, all of this can be written as an exponent. That comes from the power property. So they didn't make this up. They used the power property there. And then we need to focus on this item right here. It's odd that that entire box becomes an M. But I think if I could explain it using numbers, you might be able to see it better. If this is at all interesting to you, you can, at this point, you can pause and say, oh, I'm done. But I'm going to show you something. Let's say that B, let's give it a number. Let's give it a number like 3, okay? And let's say log base 3, because those have to match, of 27. I am going to claim to you that it will always equal what's under that highlight. So watch this. I hope you agree that this is really log, that circle right there is actually 3 because 3 to the third power is 27. And look, you end up getting 27. And you might be like, Miss Angela, you just like made up math. And I didn't, I promise, I promise. Watch this. What if we do like 4 to the power of log, this has to be a 4, and let's do 64. Well, I know that that's really 4. This answer in and of itself is a 3. And look what that answer equals. It equals 64. So I'm trying to show you that if you have a number or b raised to a logarithm of that base of that same number to the m power, that entire box will become that particular item. Like this one became 27, this one became 64. So that entire box becomes an m. Lo and behold, we just proved what we were trying to get at, that if you have an M and a B here, and you want to get it to a common log and write it as 2 logs, to do change of base, you do log of that desired common base of M divided by log of that desired common base of B. I hope I explained that well enough. If not, let me know. I'm sure I can get you there if you need it. But again, this was totally optional and not mandatory, just for those of you who are wondering why things work the way they work.